Hi guys, Mrs. Delisin here. Welcome to another lesson of AP Statistics. Today's lesson is Chapter 7, Sample Proportion. What's the proportion of orange Reese's Pieces? If you take a sample of Reese's Pieces, what proportion of the candies will be orange? Suppose a large bag of Reese's Pieces has 1,000 pieces. The manufacturer says that exactly 40% of the candies are orange. If we select a sample of 50 pieces, how many will be orange? And you already did this one in the survey that I sent to you guys yesterday. And hopefully you are understanding, even though we're not really taking a sample of 50 Reese's Pieces, hopefully you kind of get an idea of what's going on in here. What type of probability distribution does X have? When you're being asked for this type of question, you always have to think, is this binomial? Is this geometric? Is this normal? What is this? So I would always suggest that you always try to, of course, start with if it's binomial. So let's do B. B would be our success. Okay, be getting orange candies. Our failure would be not orange. Okay? Our independent, it's not independent because there's no replacement. You're taking out 50 candies and you're not putting it back. Right? So every time you take one candy at a time to take all the 50 candies, it's no longer the number of orange candies reduces, right? The number of orange candies in that bag reduces. Okay, and so it's not independent, but we've already learned before what we call the 10% condition. So the 10% condition or the 10% rule says that for as long as you're taking less than 10% of the population, you are okay. So we have 1,000 pieces, that's our population. 10% of that will be 100, correct? And we are only taking 50. So that's less than 10%. So 50 is less than a tenth of 1,000. And so it passes the 10% condition. Our N is 50. 50. Our S is the probability of success, which is 0.40, the probability of getting orange candy. So because it passes B, I, N, and S, this is a binomial distribution. Moving on. Draw a sample of 50 Reese's Pieces using the applet, which you already did, and how many pieces were orange. Repeat this 5 times and write the values below. So these are the values I got from the first, I think, 20 response. So from the first 20. So we have, what does each dot represent? So like say that. What does that represent? Okay, it represents one sample, right? It represents one sample of 50 Reese's. One sample of 50 Reese's and the number of orange candies calculated from it. Right? Okay, what is the mean and the standard deviation of the distribution of X? We know that this is a binomial distribution, and because we know it's a binomial distribution, we also know the formula for it. That is mean of X is N times P, and the standard deviation would be NP1 minus P. Okay, so NP would be 50 times 0.4, that's 20. So the mean of X is 20. Is that true? Is the mean 20? Is the middle number in there 20? It looks like true. And then that is square root of 50 times 0.4 times 1 minus 0.60. and that is 3.46. Yeah, that's correct. 3.46. So we have our mean and we have our standard deviation. Okay, moving on. What's the approximate shape of the sampling distribution? Sketch and explain it below. So is it skewed to the right? Is it normal? Is it skewed left? Right? We can tell that this one looks like normal, approximately normal, but we have to prove it using, if you remember, we are going to use the large count condition or the large count rule. What does the rule says? For as long as NP is greater than or equal to 10 and N1 minus P is greater than or equal to 10, for both of these formula goes greater than or equal to 10, we know that it would be approximately normal. So let's see if that will work. So what is our N50? Or you can already use this answer on here on the top. So we have 50.40 greater than 10. So we have 20. 20 is greater than or equal to 10. So you can just say 20 is greater than 10. You don't have to put equal, but putting that there wouldn't be wrong. So 20 is greater than 10, so we're good. And then N, so 50 times 0.60 greater than 10. That, of course, is 30. 5 times 6, 30. Greater than or equal to 10. And so, because both of this passes the condition, this is, the shape is approximately normal. With a shape, let's put the shape. So mean is 20. So that's 20, comma 3.46. Okay? Good. Instead of finding the number of candies that are orange, we will find the proportion of candies that are orange. Okay, what does that mean? So let's go back to what we have earlier. So for the kid that got 14, whoever you are, so for the kid who got 14 pieces of orange candies, 15 Reese's Pieces orange candies, if you want to get the proportion of that, do we just have to divide it by 50? So in other words, could I just say the proportion of these is 14 out of 50? Does that make sense? And that's 0.28. And can I just say that the proportion of this is going to be 21 out of 50, and that's going to be 0.42? And does that mean that the proportion of this is 20 out of 50, that is 0.4? Right? So let's make another, what's that called? Let's make another dot plot and see how the numbers will change. Do you think this shape will change? Remember, I'm dividing every single number here by 50. So I don't think that the shape will change, but the mean will change and the standard deviation will also change. Because remember, when we are multiplying and dividing a constant number, like here, we're dividing all numbers by 50, the mean and the standard deviation will both change. So, I have here my dot plot for the sampling distribution of p hat. So, I am gonna call this p hat, p with a hat, because this one is coming from a sample. Right? A proportion. Proportion. Let's just say proportion. Sample. Oh, I didn't have to erase that. Sample proportion. There you go. Okay? So what does each dot represent? So this dot right here, this is no longer, what did the dot earlier represent? Let me see. It's represented as one sample of 50 Reese's and the number of orange candy. So here, this no longer represents the number of, right? So it represents one sample of 50 Reese's candies and proportion of orange. So it's no longer the number of candies, but it's now a proportion of candies. Now, find the new mean. Please take note of the word. Find the new mean and the new standard deviation and show your work. Okay. I can tell that my mean is 0.4 because that was the equivalent of the mean earlier, right? That was the middle. And how do I convert that to 0.4? So my original mean for x was 20. But I'm not looking for the mean of x. I'm looking for the mean of the sample proportion. So because I divided every single number by 20, I would also by 50, I would also divide the mean by 50. And I will get 0.4. And now you got 0.4 over here. And because my standard, wrong notation. My standard deviation of x was, what's that one? 3.46. And I divided every single value by 50. My constant value is 50. Would that just literally also just divide your standard deviation by 50? Of course, it will just, so the mean of the, I should not do that there. That's wrong. So the standard deviation of the proportion is 3.46, also will be divided by 50. And I'm going to get that as an answer. Okay, so let's take a look. My mean of p hat is 0.40. My standard deviation of p hat is 0.0692. Now, let's try to see what's going on in here. Do you remember that our p, let me go back all the way so hopefully you're not going to get dizzy. I'm going to go all the way up here. What is my p? My p is 0.4, 0.40. My p is 40%. And then when you look all the way down here, the mean of the p hat is also 40%. So does that mean that the mean of p hat is equal to whatever the p is? It should work, correct? But here, it doesn't look like that the mean of the p hat. It looks like there is a formula going on in here. So whatever, because you know how the original formula of the standard deviation is, let me take a look, is P1 minus P, right? P1 minus P, or technically NP1 minus P. You can just do P1 minus P, and then if you notice, we're dividing it by 50. So can we just say that the formula for the standard deviation of P hat is P1 minus P over N, the square root of, sorry, I have to make the square root big deal, P1 minus P over N. Do you think that works? Let's see. Standard deviation of P hat. What's the square root of, what's P? So P is 0.4, 1 minus P, so that's 0.60, N is 50. So if I solve this, I will also get 0.92. So we now have a new formula. The mean of P hat is equal to the given P, but the standard deviation is different. It's a P1 minus P over N, the square root of that. And if you go to your formula sheets and tables, you will see that bright formula right here. Okay, so the mean of P hat is equal to P. The standard deviation of P hat is equal to P1 minus P over N. So I know there's just so many formula to memorize. Okay, what's the approximate shape of the sampling distribution? Well, the original shape was normal. So if I just divide everything by 50, the shape is also still going to be approximately normal. But our mean is not going to be 20, but our mean is going to be 0.4, comma 0.0692, and the shape would still be approximately normal, right? The shape will not change. Moving on. We know that bags of Reese's Pieces contain exactly 40% that are orange because that's what the company told us. If we select a random of 50 candies, what's the probability that the sample proportion will be 50% or greater? So let's see. 0.4, 0.4, 0.0692. So that's 0.50 or greater, so around this area, right? So probability that the sample proportion will be greater than 0.50, that, we can use normal CDF. Actually, I have to do the normal CDF. Okay, so that is normal CDF, that's menu, that's probability, that is distribution in your calculator, and then you go normal CDF. Because I don't have a space in there, sorry guys, let me put it all the way in the bottom. P hat is greater than 0.50, so I'm going to be norm CDF. I will put greater than 50, so 0.50 is my lower bound. And then I have 1,000 on the upper bound. Right? So 0.50 is your lower bound. 1,000 is your upper bound. Your mean is 0.40. And your standard deviation is 0.0692. So let me also do that. That's 0.40, 0.0692. Click enter on your calculator and you'll get 0.0742. Okay? As an alternate, you can also use your calculator, and then you can use your table. So let's use the table. So that's z equals x minus the mean. So 0.50 minus 0.40 divide by 0.0692. That is 1.45. You go to table A. Can you guys make sure you confirm this? 1.45 to the left is 0.9265. But you don't want to the left because you want the right side. So that's 1 minus 0.9265. That's also 0.07. Okay, it might not be exactly the same. I think it might be 0.07. Let me put it on. I think it might be 0.735. Yeah, it's 0.0735. And then it doesn't match with my calculator and my table, but they are around 7%, so that's okay. So you need to really make sure that you mention which one you used, because if you use the table, you have a slightly different answer from using the calculator. Okay. What else we have here? We have our important ideas. So what is our important ideas? What are the formulas that we have used today? We use that the mean of p hat is equal to p. We know that the standard deviation of p hat is p1 minus p. What's going on? P1 minus p over n. My pen is not working. Okay. P1 minus p over n. And then make sure that the 10% condition is met. Okay. And then we also have large count condition. You'll use large count if you want to see if a certain distribution is approximately normal or not. So approx normal. And what did you do? NP greater than 10 and 1 minus P greater than or equal to 10. Okay, what else do... Oh, we could also, for the Z, so that's P hat minus P over P1 minus P over N. Do you know how I did the table A thing? So I did 0.50 minus 0.40. Yeah, so the P hat, the sample proportion given, minus the P, which is the mean, over, I already showed you how to do that. Okay, according to the American Dental Association, 8% of adults have never had a cavity. 8% of adults. A dental graduate student contacts an SRS of 1,000 adults and calculates the proportion in the sample who have never had a cavity. Identify the mean of the sampling distribution. So, this is not going to be the mean of X, right? The mean of the binomial, which is NP, not anymore. But we're talking about proportion in here. So the mean of over here, the mean of one population, which is mu, let's change the color, mu of P hat is equal to P. So if our P is 0.08, so our mean of P hat is also 0.08. Where did I get the 0.08? I got that from the given 8%. 8% is 0.08. Moving on. Calculate and interpret the standard deviation of the sampling distribution. Checked that the 10% condition is met. Let's check if the 10% condition is met first. We're taking 1,000. Is 1,000 less than 10% of all adults in America? Or because it says American Dental Association, so that means we're just talking about America here. So 1,000 is way obvious that it's less than 10% of all the American adults. So we're good. We can use our standard deviation formula. Should I write it first? Okay, let's write it first and then we will we'll substitute. Okay, our P is of course 0.08. So 0.08 times 1 minus 0.0. So can I just put 92 over 1,000? And that is 0.009. I think, hopefully, please make sure to check my answer. Is the sampling distribution approximately normal? Check the large count condition is met. So, MP greater than or equal to 10, and 1 minus P greater than or equal to 10. So many conditions to remember, yeah? So, our N is 1,000. Our P is 0.08. And, greater than or equal to 10. What is that one? 80. So 80 is indeed greater than or equal to 10. 1,000.92 greater than or equal to 10. That's 920 greater than or equal to 10. So both of them are greater than or equal to 10. So the large count condition is satisfied. This is approximately normal. So we should put approximately normal. Okay. Find the probability that a random sample of 1,000 adults will give a result within 2 percentage points of the true value. What is 2 percentage point? So 2% or 0.02. Right? Okay. So, find the probability. N is, what's our N? Oh, sorry, what is our mean is 0.08. And our standard deviation is 0.009. So this is 0.08. So when we are being asked, we'll give a result within 2%. So what is that? 0.08 plus 0.02, 0.08 minus 0.02. Does that make sense? So 0.10 and 0.06. Right? So what's the probability? Maybe I can make that smaller. 0.08. So probability of 0.06. And I'll just make it bigger so that I can see it. Because if we make it, because it's really small, but if we make it too small, we can't see what we're trying to get. So we're getting the between part, and it's really easy if we use the calculator for this. So I'm going to do P, probability of P hat is 0.06, 0.10. So the probability that the proportion will be in between 0.06 and 0.10. So if you do that in the calculator, it's very easy to go to normal CDF, 0.06, 0.10, 0.08, 0.009. So let's do that in the calculator. I'll go menu, statistics or probability, doesn't matter. Go to distribution and then go to normal CDF. So you put 0.06 as your lower bound, 0.10 as your upper bound, 0.08 as your mean, and 0.009 for your standard deviation. And I have to make sure that I name mean is 0.08. Standard deviation is 0.009. When I click enter, I will get 0.07. Okay? And hopefully you got the same answer. You got 0.07. Okay, so what else do we have to... normal CD... Wait. No. I type it wrong. That is too little. Should be bigger. Okay, wait. Let me see. I put 0.5. Oops. Sorry, guys. So I get normal CDF. I got 0.06, 0.10, 0.08, 0.009. And there you go. That's better. 9737. So over here, let's make that bigger. Okay, so we have 97%, 97.37% will give us a result within 2% of the true value. Because the true value was 0.08, right? Because it was given 8% doesn't have developable cavity. Okay, moving on. If the sample size were 9,000 instead of 1,000, how would this change the sampling distribution? Okay, if the sample size were 9,000 rather than 1,000, it wouldn't change the mean, right? Because the mean will still be 8%. So the mean is the same, and distribution would still be approximately normal. But remember we said before that when you increase the standard deviation, when you increase the sample, the standard deviation will decrease. Right? When you increase the sample, standard deviation will decrease. So the variability will decrease. The standard deviation will decrease. And let us see if it's true using the formula. So I have, okay, let me just use the formula for standard deviation when it's 1,000. So I have 0.08, 0.92 over 1,000. And we know that the answer that is 0.009. And then if I use the same formula, but instead of 1,000, I'll put 9,000. And I'll get 0. You guys need to confirm. I'll get 0.03. So is it true that the standard deviation will decrease? It is. And how much it will decrease? It'll decrease by 1/3, right? 9 divided, so you have 3 divided by 9. So it will decrease by 1/3, right? It will decrease by 1/3 of the value. Okay, but the mean will stay the same. The shape will stay the same. It'll still be normal. There you go. Thank you guys for your patience, and I hope this will help you understand the current lesson, sampling distribution or sample proportion. I will see you guys on the next video, and thank you. Bye.